What happens when highly trained astronauts, people selected specifically for their observational skills and mental stability, encounter something they can't explain? And why do these accounts often disappear from official records? In 1963, Mercury astronaut Gordon Cooper tracked an unidentified object on radar before watching it land on a dry lake bed. In 1981, cosmonaut Kovalyanok observed an object that split in two before vanishing. These accounts come from elite space travelers with rigorous psychological screening. What drives seasoned professionals to risk their reputations by reporting such encounters? And what about the Apollo 11 crew's mysterious bogey report that NASA initially classified? The stories continue to challenge our understanding of what's truly out there, the unique perspective of space explorers. When we talk about unexplained aerial phenomena, there's a fundamental difference between reports from random civilians and testimonies from astronauts. The distinction isn't just about credibility. It's about the unique qualifications these space explorers bring to their observations. Astronaut selection begins with a process that eliminates all but the most exceptional candidates. NASA typically receives thousands of applications for each astronaut class, but selects only a handful. The psychological screening identifies individuals with unwavering mental stability through crisis simulation stress tests and interviews with psychiatrists trained to detect even subtle psychological issues. This selection focuses heavily on observational skills. Astronaut candidates must demonstrate exceptional ability to notice details, maintain situational awareness, and accurately report what they see. Like elite detectives at a crime scene, they must capture every relevant detail while filtering out distractions. During one training exercise, candidates observe a complex simulated spacecraft malfunction for just 30 seconds, then must recall specific gauge readings, warning light patterns, and sequential events, skills that prove crucial during potential anomalous encounters. Many astronauts come from test pilot backgrounds, a profession demanding precise observation under extreme conditions. Others have scientific backgrounds requiring meticulous documentation of phenomena. Their technical knowledge allows them to rule out equipment anomalies that might confuse others. They can distinguish between known space phenomena like ice crystals from spacecraft venting, space debris in predictable orbits, or reflections from solar panels. Once selected, astronauts undergo specific training in observational protocols beyond spacecraft operation. They learn to distinguish between known space phenomena and truly anomalous events. This training includes exposure to optical illusions common in space and techniques to compensate for perceptual distortions caused by the unusual conditions of spaceflight. Documentation protocols for unusual sightings are rigorous. Astronauts record precise details: observation time, duration, apparent size, distance, movement patterns, color, luminosity changes, and relationship to known objects. They sketch or photograph anything unusual and immediately log observations in mission reports because space agencies understand novel phenomena might have scientific significance. Space agencies have historically handled these reports through classified channels. During the space race, both NASA and the Soviet space program maintained separate reporting systems for unusual sightings not included in public mission transcripts. This compartmentalization reflected Cold War concerns about potential military implications of unknown objects in space. Astronauts apply scientific methodology to their observations, avoiding speculation about origins and focusing on observable characteristics. They consider multiple explanations and include contextual factors that might affect perception, such as spacecraft orientation, lighting conditions, and their physical state during observation. According to NASA historian Stephen Dick, approximately 12% of astronauts across various space programs have reported unexplained phenomena during missions. This figure likely underrepresents the actual frequency, as many reports remain classified decades after missions concluded. Many sightings are documented in technical debriefings, but omitted from public mission reports. The Russian space program has historically been more transparent about these encounters. Cosmonaut accounts of unexplained phenomena appear more frequently in official mission documentation, though still with careful scientific language. This difference likely reflects different institutional cultures rather than differences in actual observations. These accounts are significant because they come from individuals specifically selected for objectivity and reliability. Astronauts understand space physics and optical phenomena at an expert level, while maintaining analytical thinking even in life-threatening situations. Consider the professional risk when astronauts report these encounters. Their careers depend on being perceived as reliable, rational observers. Making claims about unexplained phenomena potentially jeopardizes their professional standing, creating a reporting bias likely to suppress rather than exaggerate unusual encounters. When they document unexplained phenomena despite these risks, it suggests they believe the observations have genuine significance. The combination of psychological stability, observational training, technical knowledge, and professional risk creates a witness profile of exceptional reliability. While this doesn't automatically validate every unexplained sighting, it means we should pay particular attention to phenomena that puzzle these qualified observers. Perhaps most compelling is the consistency across different space programs, time periods, and individuals. Despite coming from different countries and backgrounds, certain patterns emerge in descriptions of unexplained phenomena, particularly regarding movement patterns that defy known physics and technology. One such pattern involves objects displaying instantaneous acceleration from stationary positions, something we'll explore in greater detail when examining specific cases.